So in this video we'll be learning about direct comparison test, and there are two conditions that you need to know. So the first condition is, let's say we have a sequence of a of n, and we need to compare this sequence of a of n to another similar sequence. Let's call it b of n, and the first condition is that b of n has to be more than or equal to sigma or sequence of a of n, and b of n is converging. So this is very important. Converging. So let's draw a graph to visualize this. So I'm gonna draw it over here. Let's call b of n this line, and we know that it's converging to a number here. So it's a finite number, right? This is b of n, and we said that b of n is more than or equal to a of n. So if we draw a of n over here, it has to be less than this line, right? Because b of n is always more than a of n. So a of n will look something like this. It can never go above this line. And if b of n is converging, this means that definitely a of n has to converge also. So that's the logic behind this. Let me just put this aside, and now let's do the second condition. So 2 sigma a of n again, and b of n. This time b of n is less than or equal to a of n. Basically a of n is more than b of n, and the other condition has to be that b of n is diverging. So the first step that you think of is, when you get a value, we'll do a lot of examples of b of n. We check first if it's diverging or converging, and if it's either of these two cases, then we see if it's more than or equal to a of n. So this time b of n is diverging and it is less than a of n. So again, if we draw the graph over here, b of n is going to infinity, so it's always increasing. Let's call this b of n, and if we see a of n is also increasing, it's more than b of n. So here, if I change my color to red, a of n has to be more than b of n in this graph, right? It can never go below it, or here it has to be above it. So these are the two conditions that you need to follow. So in the first case, a of n has to also converge, and in the second condition, a of n is diverging. So now let's go over when this you cannot use DCT, direct comparison test. So let's say we have again sigma a of n that we need to find, and we are comparing it with sigma b of n, and let's say that a of n is more than b of n here, and we know that b of n is sigma b of n is converging. So what does this mean? This is not any of these conditions, by the way. If you can see, it is more than a of n is more than b of n, but here we need that b of n is diverging. So what happens if this question is like this? So if we draw the graph here, let's draw it for b of n. So we know that it's diverging to a number. So it's going down and it's going to a number, it's approaching a number. Let's call this b of n. And here we have that a of n is more than b of n. So we don't know if it's going to converge, or it can even diverge to infinity. It can be like increasing rapidly, or it could be decreasing. We never know. So in this case we cannot use DCT. So the only conditions that you need to follow are these two, which are stated over here, and you need to check for if it's more than or equal to. And let's now do some examples. So our first question is the sequence from n is 1 to infinity cosine squared n over n to the power of 3 over 2. So before we use the method that we just learned, we are going to go over why we cannot use the other methods. So first thing is that we cannot use geometric because we don't have a constant. Cosine of n is constantly increasing or decreasing. And this is not a polynomial because we cannot use telescoping sequence that we learned before. And if we apply the nth term test here, we are going to get cosine. The maximum value of cosine is 1, and it's going to be 1 over n infinity to the power of 3 over 2. So this is equal to 0, which means that the n term test does not work also, it's indecisive. So in DCT now, we somehow need to come up with a sequence which has a similar behavior to cosine squared n over n to the power of 3 over 2. Let's just call this a of n. So let's call this b of n. So here, if we look at the numerator, we have cosine squared n, and we know that the maximum value of a cosine of any value, let's call it x here, any value of x is gonna be 1, right? The maximum value here. It's always between -1 all the way to +1. So here, what we can do in the numerator is we can replace cosine squared n with 1, and for the numerator, and so in the numerator we have the same thing because we cannot replace this. This is always going to positive infinity as n is going to infinity. This is also going to go to infinity. And here we know that b of n is going to be larger than the left hand side a of n, since in this part we have the cosine squared n from any value from -1 to 1, and here we only have 1, which is the maximum value. So that is why the right hand side is more than the left hand side. So now what we need to do is we need to evaluate this right hand side, which is b of n. And if you look in this sequence, what is this sequence series called? This is called the p series. And if you have watched my other video, it looks like 1 over n to the power of p. And here in our case, the p is gonna be 3 over 2, which is more than 1, and in that case this p series converges. So here we know that b of n is converging. So now let's draw the graph. I'm gonna call this b of n, and this is converging. So you can also just draw a straight line, and here we know that b of n is more than a of n. So here a of n is gonna be less than b of n, which is also going to converge. And that's it for this question. So in this question we relatively had easy b of n, but sometimes it's very difficult to evaluate and find the b of n and like compare it to the original a of n. So let's do more examples. So our second question here is a of a is 1 going to infinity. We have 5 over 5n minus 1, and now we need to evaluate this sequence or series. So what is the first thing that we can do? We can write, instead of 5 here, we can do 1 over 5n minus 1, since if we look here, n is always approaching to infinity, and let's say 5 over infinity is also 0, and 1 over infinity is also 0, right? It's almost the same thing because you're going to be dividing by infinity, and it does not matter if there is a finite number in the numerator. So what else can we do over here to even make it more simpler for us? We can also get rid of this minus 1, since n is going to infinity, and infinity minus a finite number, let's say 1, is also infinity, right? So let's drop the 1 here. And is there any other thing that we can do here? We can also just remove this 5, since 5 multiplied by infinity is infinity, and infinity is also infinity, right? You get what I mean. So we can also drop the 5, and now all that we are left with here is 1 divided by n. And let me just write the series. Infinity n is 1, and we know that this is harmonic, which means that it is diverging. Now the last thing that we need to do, actually this should be the first step that you do after getting the b of n, is whether you need to check if it's less than or equal to a of n or more than, because that depends on the entire condition. And here in this case it is not easy to see if it's more than or less than equal to. And a quick way to do that is to substitute a big number, let's say 100 or 1000, not like small numbers from like 1 to 100, maybe like 100, 1000 or something like that. So let's substitute 100 is going to be 5 over 500 minus 1, and on this side is going to be 1 over 100. Now just compare these two, is going to be 5 divided by 499 and 1 over 100. And here we know that 1 over 100 is more than or equal to 5 over 499. This is going to be very close to 1 over 100, but 1 over 100 is more than this number. So here let's write more than or equal to, and we know that this is the second condition, so this part has to be also diverging. So this is a very important step, by the way. Just take, if you don't know which one is more than or less than equal to, just take a big number, let's say 100, 1000, and compare them, and you will find out which is more than or equal to, or sorry, less than equal to. Oh my, I made a small mistake here, sorry guys. This is more than or equal to, just a small, no, I tried to do it in my head and I should just use my calculator. So 5 over 499 is more than or equal to 1 over 100. This means that this is more than or equal to, and if you now draw the graph, it's going to make more sense. So let's call this b of n. It's going all the way to infinity, and we know that a of n is more than b of n, so the line has to be above this, and both of them are going to infinity and diverging. So again, don't make this silly mistake, just type it on your calculator. You will get that 5 over 499 is more than or equal to 1 over 100. So one small tip is that always draw the graph in the end and compare, because this really helps you visualize when you're comparing both a of n and b of n and seeing which one is diverging or converging. So let's do more examples again. So question 3 now, we have the limit, or sorry, the series from n is 1 to infinity, and we have 1 over n squared plus 1. And now we need to compare this to a b of n, which is similar. So let's keep the numerator same. It's going to be 1 over, we can get rid of this plus 1 here, so we're going to be left here with n squared. Now one thing to keep in mind is that we cannot replace or get rid of these powers. So let's say if it's n squared, we cannot write n because that squared makes a huge difference. And let's say in p series or whatever the other tests are, this is the key factor, whether it's converging or diverging. So the best substitution that we can do here is 1 over n squared, and this is also n is 1 and is going to infinity. And here we know that this is the p series, and here p is equal to 2, which is more than 1, which means it's converging. So now we need to check if it's more than or less than. So here you can just substitute a big number like 100 n or check, or you can just see that, you know, whenever the denominator is bigger, it's going to be a smaller number, right? So 1 divided by 101 is smaller than 1 divided by 100. So here you can do b of n is more than or equal to a of n. So we know that this is converging. This has to also converge by dct. And if you draw the graph here, this is b of n, it's converging, and a of n has to be less than b of n, so it also is bounded by this line and it's also converging. So that's all for this video. If you have any questions about any of the questions, feel free to ask it in the comment section. And in our next video, we'll be covering limit comparison test, and that will be done in the next video. Thanks for watching.